Dean Gallea here for the TarryHollow Repair Cafe. We're going to be looking at another microwave repair. We have a retro-styled microwave oven here that says from Nostalgia Electric that doesn't work, belongs to a friend of mine. And what happens is, I have my test cup of water in here. When I turn it on, there's a loud hum. The timer counts down. The turntable turns, the light goes on, but nothing gets hot. It doesn't cook. So, what clues does this give us? Well, first of all, we know the main fuse isn't broken because everything except the heating works. And we know that the door switches seem to be working okay because they energize. That loud hum obviously comes from the main power supply for the Magnetron that's in there. So we know that the door switches are working, allowing the power to get to the main part of the heating part of the microwave oven. So we're going to go inside and investigate what could be wrong other than what we just mentioned. Okay, I've carefully removed the cover from the microwave. I believe it had 6 screws to get the cover off. And I've unplugged the microwave initially, put the plug right here. I like to see that plug while I'm working on a device so that I know it's not plugged in. And I want to talk about a couple of precautions that you need to be concerned with working on a microwave inside. One is that this guard right here, this piece of plastic, is there because there's terminals for a very high voltage capacitor inside. Could have hundreds of volts on it, could be dangerous. So we always need to check to make sure that capacitor has been discharged. I have my voltmeter, multimeter on DC here because if there's any residual charge it's going to be direct current. And I'm going to probe the capacitor, and in fact it reads 0, so there's no stored voltage in here that I need to be concerned about. If there was, I'd have to take a piece of insulated wire stripped at each end and short that across the capacitor to relieve any power that's remaining in there. So because we know that power is getting to the transformer, we hear it humming. And just to review how a microwave works, the transformer has a very thick winding at the bottom that's connected to the AC line, and it has a very thinly wound with very fine wire secondary winding that brings the voltage up from the regular 110 volts to several thousand volts to power the Magnetron, which is this unit here. The Magnetron has a couple of connections to it. These two connections are to basically the filament that's inside there. Like it's really a vacuum tube that has a resonance that high voltage causes. Very powerful RF radiation goes into the chamber to cook the food. The voltage across this filament inside there is fairly low, just a few volts. The main voltage is between the filament winding and the ground, which is basically the case of the microwave oven. That's where the high voltage gets in there. So how do we troubleshoot a Magnetron? Because that's the most likely thing to fail. If the power transformer had failed or shorted, it would probably blow the fuse. But the Magnetron is getting its voltage from the power transformer. It's just not getting the RF into the chamber, into the microwave cavity to cook the food. So let's start with the premise that there's something wrong with the Magnetron. So there's a few things we can check on the Magnetron. One is the resistance of the filament winding should be fairly low, like a matter of a few ohms. because it's high current, low voltage. The resistance between the filament windings and the case should be very high, because the high voltage that powers the magnetron resonates in there. It doesn't have a direct ohmic connection to the filament windings. So the filament windings should be basically very low ohms resistance. Between either of these terminals and the case should be virtually no connection, in the very high millions of ohms, if anything. So let's first try checking the resistance across the filament windings, which I can do very easily. I'm going to put this on the ohms range. All right. And we're going to check resistance across the windings, and sure enough, it's reading 0.2 ohms, which is virtually shorted, which is what it should be. The filament winding is a piece of metal inside that heats up, and that should be a very low resistance. And just to be sure, we can also check the resistance through the filament winding of the transformer, which should also be low, because it's powering a high current at a low voltage. And sure enough, that's reading 0.4 ohms. So we know that the filament winding is okay, and we know that the filament connection inside the magnetron is okay. All right, next let's check the resistance between either of these and the case. And what I'm reading here is 38 ohms. That should be virtually an infinite resistance. So the magnetron is shorted, but there should be no short between the filament windings and the case of the magnetron. And that's where the high voltage appears. That's why we're getting the loud hum, because the transformer is trying to power it, and it's just getting shorted out inside. So good thing we didn't leave it on too long, because the transformer might have overheated and caused a thermal fuse to blow. And essentially we need to replace this magnetron. There's no way to repair the internal workings of the magnetron. It's sealed. It's supposed to be sealed. It's a safety item. It's not supposed to be user repaired. But we can easily buy a new magnetron online. They're not that expensive. It's about $60. So I'm going to show you how to replace the magnetron once you get a new one. So just to illustrate what we're going to do, the magnetron's held on by 4 screws. 2 of them are over here, and 2 of them are behind this shroud here that is a cooling plenum to have the fan cool the magnetron, and also to force air through the cooking cavity. So this plenum is held on by 2 screws up here. So I have to take those off in order to get to the 2 that hold the magnetron on this side. Also have to take off this overheat protecting device on the top here, which is screwed into the magnetron chassis. This is actually the new magnetron that we're going to put in. You can see it's a fairly hefty unit. This little hole here is where the RF energy comes out to cook the food. This is just a connecting conductive piece to keep the RF well contained. We don't want it to get out other than inside the chamber to cook the food. So there's a gasket here that's made of gold-plated copper, and you know, it looks pretty much the same as the one that's there. So we're going to replace that. I just wanted to illustrate here. This is with the magnetron removed. Also, the plenum here has the bulb in there that lights up the interior of the microwave. I'm just going to leave that hang right there. Okay, the new magnetron is in place. I've reattached the overheat device at the top here with self-tapping screws. Got the shroud back on, also some self-tapping screws that fit the holes in the new magnetron. I've reattached the filament wires down here. Push them out of the way a little bit, and I'm going to reinstall the case, and we'll see how it works. One more thing to check when you are replacing the magnetron on a microwave. There's a mica window. It's made of a non-conductive material that can take high heat. That's between the magnetron and the cooking chamber. That mica window, if the magnetron were to fail in a way that's causing an arc, or if anything arcs to this from inside, metal pan, let's say, you would see darkened spots on this mica window. That's a sign that you need to replace it with a new mica window. And you can get this material, you have to cut it to the right size. But in this case, there's no signs that there's been arcing. There's a little dark spot here. I think it's just spatter from some food. So we're gonna, I put the cover back on. We're gonna try this out now. I'm gonna put my test cup of water inside. It's been plugged in. The display is working. I'm going to heat that water for about 20 seconds. Sounds like it's working okay. Don't hear a loud hum like we did before. Lights on, the turntable's turning. The countdown timer is working. And sure enough, the water is hot. So we've got this back in working order. I'm going to assume that that bad magnetron was the only thing wrong with it. And we've repaired this microwave. So just to reiterate, we didn't find anything wrong with the switches. We didn't find a blown fuse. We did hear a loud hum. We checked the magnetron and it was internally shorted. We replaced the magnetron and the oven is working again. Alright, so thanks for watching, and I hope this helps with your repairs.